Imagine a storm so vast it could swallow our entire planet. Not just once, but maybe 2 or 3 times over. This isn't science fiction. This is a real place in our own solar system. We call it Jupiter's Great Red Spot. For centuries, this swirling crimson vortex has been the most famous feature on the giant planet. It is a cosmic landmark, a familiar face in the heavens. We have seen it in countless textbooks, documentaries, and stunning NASA photographs. It is as iconic to Jupiter as the rings are to Saturn. It has always been there, a constant presence in our exploration of the cosmos, a symbol of the immense power and mystery of the universe. But what if this icon was disappearing? What if this colossal storm was slowly but surely fading away? This is the shocking truth that scientists are now facing. The Great Red Spot is shrinking. It is not the immense tempest it once was. Astronomers have been watching it for a very long time, and the evidence is undeniable. The storm is getting smaller, its powerful winds are changing, and its once oval shape is becoming more circular. This change raises so many questions. Why is this happening? What does it mean for Jupiter? And what can it teach us about the giant planets that roam our solar system? The mystery of the shrinking spot is one of the most exciting puzzles in modern astronomy today. This is more than just an astronomical observation. It feels like we are watching a piece of history vanish before our eyes. The Great Red Spot has been a source of wonder and curiosity for generations. Early astronomers peered through their simple telescopes, sketching this strange blemish on Jupiter's face. Our story begins over 350 years ago, in a world lit by candles and powered by curiosity. It was the 17th century, a time of great scientific revolution. Astronomers were pointing newly invented telescopes towards the heavens, and the solar system was revealing its secrets one by one. In England, a brilliant scientist named Robert Hooke was one of these pioneers. In 1664, while observing the giant planet Jupiter, he noticed something peculiar. He saw a small dark spot moving across the planet's southern hemisphere. He meticulously sketched what he saw, documenting this strange blemish on the face of the gas giant. A year later in Italy, another famous astronomer named Giovanni Cassini observed a similar feature. He called it the permanent spot because he was able to track it for several years. Cassini used this spot to measure Jupiter's rotation, calculating that the giant planet spun on its axis in just under 10 hours. This was an incredible piece of detective work, using a distant storm as a cosmic clock. His observations provided the first real evidence that other planets were dynamic worlds with their own unique characteristics, not just simple points of light in the night sky. However, after 1713, the spot mysteriously vanished from astronomical records. For over a century, no one reported seeing it. After its curious disappearing act in the 18th century, the spot made a dramatic comeback. In the year 1831, an amateur astronomer named Samuel Heinrich Schwabe produced a detailed drawing of Jupiter that showed a clear, though small, oval shape. From that point on, the sightings became more and more frequent. The storm, it seemed, was back. But it was in the late 1870s that the Great Red Spot truly announced its presence to the world. It grew in size and deepened in color, becoming an unmistakable brick-red feature. This was the beginning of the modern era of Great Red Spot observation. It was no longer a faint, elusive blemish that only the most skilled observers could find. It was now a bold, unmissable landmark, and astronomers around the world began to study it with intense interest. They gave it its now famous name, the Great Red Spot. It was great because its size was simply staggering. Astronomers calculated it was wide enough to swallow the Earth multiple times, and it was red for its striking, unusual color, a hue that stood out dramatically against the pale yellow and beige bands of Jupiter's clouds. It captured the public imagination in a way few astronomical phenomena ever have. For the next century, the Great Red Spot was a constant. It was a reliable feature, a permanent fixture in the turbulent and ever-changing atmosphere of Jupiter. While the clouds and belts around it would shift, merge, and change color, the spot endured. To truly understand the Great Red Spot, we needed to go there. This dream became a reality with the dawn of the space age. In the 1970s, NASA launched a pair of robotic pioneers, Voyager 1 and Voyager 2, on a grand tour of the outer solar system. Their flybys of Jupiter in 1979 were a watershed moment. For the first time, we saw the Great Red Spot not as a distant smudge, but as a vibrant, churning, and incredibly complex weather system. The Voyager's cameras revealed the intricate swirls and eddies within the storm, and the violent interactions at its edges, where it scraped against the surrounding atmosphere. The data they sent back was stunning and completely reshaped our understanding. They confirmed the spot was an anticyclone, a high-pressure system, and measured its ferocious wind speeds for the first time. Following the trail blazed by the Voyagers, the Galileo spacecraft arrived at Jupiter in 1995. Unlike its predecessors, Galileo did not just fly by. It went into orbit, becoming Jupiter's first artificial moon. It also did something incredibly daring. It dropped a probe directly into Jupiter's atmosphere. While the probe did not enter the Great Red Spot itself, it gave us our only direct measurements of the temperature, pressure, and composition deep within the planet's clouds. That wait ended spectacularly in 2016 when NASA's Juno spacecraft successfully entered orbit. Juno is not like any mission that came before it. It was designed specifically to solve the biggest remaining mysteries about the gas giant. To do this, Juno flies in a unique, highly elliptical polar orbit. This path takes it soaring high above the poles and then swooping down to skim just a few thousand kilometers above the cloud tops, flying closer to Jupiter than any spacecraft in history. Its main camera, JunoCam, is not just a scientific instrument. It is a public outreach tool, and its raw images are posted online for citizen scientists to process. This has resulted in some of the most stunning, detailed, and artistic views of the Great Red Spot ever produced. So, we come to the heart of the mystery. Why is the Great Red Spot shrinking? When modern observations began in the late 19th century, the spot was an immense oval stretching over 40,000 kilometers wide. At that size, you could have lined up 3 entire planets the size of Earth across its diameter. Even today, in its diminished state, measuring about 16,000 kilometers across, it is still wider than our home planet. By the time NASA's Voyager spacecraft flew past Jupiter in 1979, the spot had shrunk, but it was still large enough to hold 2 Earths. Today, it can barely contain one. Its shape has also changed from a long oval into a more compact circle. The change is so dramatic that scientists are seriously asking if the Great Red Spot might break apart and disappear completely within our lifetimes, perhaps in just a few decades. The most straightforward theory is perhaps the most intuitive one. The storm is simply running out of energy. Think of the Great Red Spot as a colossal spinning top, set in motion centuries ago. For a very long time, it had enough rotational energy to overcome the forces of friction and drag from the surrounding atmosphere. Another leading theory suggests the Great Red Spot is not just dying of old age, but it is being actively dismantled by its neighbors. While the Great Red Spot is the king, it's surrounded by a court of smaller, younger vortices. It's now more vulnerable to these smaller storms, which are like piranhas, nipping and tearing at its edges. A compelling theory suggests that the shrinking of the spot is linked to long-term changes in the jet streams. An accelerating jet stream would increase the shearing force on the spot's northern edge, essentially eroding it more quickly and forcing it into a smaller, more compact shape. In recent years, astronomers have observed a new and dramatic behavior. The Great Red Spot has started to flake. Observers have watched as huge streamers of red material, sometimes thousands of kilometers long, suddenly detach from the main body of the storm. Scientists have linked these flakes to collisions with smaller storms. When a smaller vortex smashes into the side of the Great Red Spot, it can act like a wedge, prying a section of the storm's outer band loose. Each flaking event represents a significant loss of mass and momentum, contributing directly to the storm's shrinkage. However, the storm has proven to be more resilient than it looks. While these flaking events are dramatic, the Great Red Spot has so far managed to recover from them. After a flake breaks away, the main vortex tends to pull itself back together, reforming its circular boundary. Studying a phenomenon as complex and dynamic as the Great Red Spot is not a job for a single person or a single instrument. It requires a massive, coordinated effort from scientists all around the world. The modern approach to understanding the storm is a global collaboration. This effort brings together space-based telescopes like Hubble, robotic explorers like Juno, and a network of powerful ground-based observatories. For instance, when the Juno spacecraft is scheduled to make a close flyby of the Great Red Spot, a call goes out to astronomers around the globe. This is a global effort that even includes amateur astronomers. The community of dedicated backyard observers plays a vital role in monitoring Jupiter. With modern digital cameras and telescopes, amateurs can produce incredibly high-quality images. They can track the movement of the Great Red Spot and other storms on an almost nightly basis, providing a continuous stream of data that professional observatories, with their limited and highly sought-after telescope time, simply cannot match. Each wavelength reveals a different layer of the storm, like peeling back the skin of an onion. Infrared light, for example, can tell us about the temperature of the clouds, revealing that the center of the spot is relatively cool, while its edges are warmer. Together, these eyes on the giant paint a rich, multi-layered portrait of the storm, a portrait that becomes more detailed with every passing year. By weaving all these different threads of evidence together, scientists can build and refine their models. The slow demise of the Great Red Spot is more than just a celestial spectacle. It is a unique and invaluable scientific opportunity. For planetary scientists, the storm has always been a natural laboratory for studying fluid dynamics on a scale impossible to recreate on Earth. This knowledge is not just applicable to Jupiter, it helps us understand the atmospheres of other giant planets like Saturn with its own massive storms, and even the thousands of exoplanets we are discovering around other stars, many of which are gas giants like Jupiter. By testing our weather models against the extreme case of the Great Red Spot, we can refine them and make them more robust. If a model can successfully predict the changes happening on Jupiter, it gives us more confidence in predicting complex weather systems on our own planet. The importance of this cosmic laboratory extends to our search for life elsewhere in the universe. By studying the chemical processes happening within the Great Red Spot, we gain insight into the kinds of prebiotic chemistry that can occur in planetary atmospheres. Ultimately, watching the Great Red Spot evolve is a lesson in the dynamic and ever-changing nature of the cosmos. It reminds us that nothing in the universe is truly permanent. Features that have existed for all of recorded human history can change and disappear within our lifetimes. This challenges our perception of the solar system as a static, clockwork mechanism. Instead, we see it as a living, breathing system full of complex processes and life cycles. Even with all our advanced tools and theories, the Great Red Spot continues to guard many of its secrets. Perhaps the most fundamental unsolved puzzle is the storm's ultimate fate. Will it disappear completely? If so, when? Some models predict it could vanish within the next 20 years, while others suggest it might stabilize at a smaller size. Another major question mark hangs over the storm's energy source. We still do not have a complete picture of what has powered this behemoth for so long. The mystery of its distinctive red color also remains officially unsolved. Finally, the biggest question of all might be, what comes next? If the Great Red Spot does dissipate, what will take its place? The end of the Great Red Spot might just be the beginning of a whole new chapter in our exploration of the giant planet. Our journey to the King of Planets has brought us face to face with one of the greatest mysteries in the solar system. We have traveled back in time to witness the first glimpses of the Great Red Spot through the simple telescopes of the 17th century. We've marveled at its colossal scale, a storm wider than our own planet, with winds faster than any hurricane on Earth. Now we find ourselves watching its slow, majestic, and perplexing fade, a spectacle of cosmic change unfolding before our very eyes. The shrinking of the Great Red Spot has transformed it from a permanent landmark into a live scientific experiment. The answers we seek matter far beyond the fate of a single storm on a distant planet, and so we continue to watch. We watch as a feature that may have raged for over 3 centuries evolves, shrinks, and changes. We do not know if we are witnessing the end of an era or merely a transition to a new state. Will the Great Red Spot vanish into the beige clouds of Jupiter within our lifetimes, leaving behind only memories and data? Or will it find a way to stabilize, a smaller but still potent vortex fighting for survival? Whatever its destiny, the story of the shrinking spot is a powerful reminder of the dynamic, ever-changing nature of the universe. It is a story of immense power, slow decay, and enduring mystery, a a story that continues to captivate and inspire us as we look to the heavens and wonder,